springs. It's a mechanical device used to store the energy, and in another way it can be also said as the mechanical device used to absorb the energy. Anyway, in designing a spring, the terminologies that come under within a helical spring, the spring that I am holding in my hand is a helical spring. You could see a diameter of this wire that is used to develop this spring. The diameter of wire is termed as small d. This inside diameter is termed as inside diameter of a spring, which is termed as di. Outermost, the outside diameter of a spring is said as do, and the mean diameter in between, which lies in between the outer diameter and inner diameter, is d, capital D. Now, very important concept when it comes to a spring is number of coils, which is termed as small I. Now, when I say a terminology or a design of a spring, there is one thing where we need to be very much into. What is this active and inactive coil? So, to understand that, look at the spring. Let me say that active springs are the one which takes the deformation, and inactive springs are the one which doesn't take any deformation, that sense out, it doesn't be involved in a design, but in fact it acts as a supporting member for the either the sides. For example, if you could see the springs, there are around two inactive coils, one on the top and another at the bottom. If I say these two, the springs been supported between two supports. Therefore, this one and this one are the two inactive coils, and these 1, 2 are the active coils. So therefore, whenever I say number of turns, it would be 2 inactive coils and 2 active coils. So whenever I apply a fully loaded condition, when the spring is at fully loaded condition, sense out, when the coils are quite adjacent to each other, this length is said as solid length. In a similar way, when the load is of free load, when the spring is of no load, the whatever the length that we see is an free length, which is in terms, the deformation is termed as y, solid length as ls, and free length as lf.